In this video, we are going to perform the demonstration for network policies. So to perform this demonstration, the very first prerequisite is the AKS cluster. So we have already seen a couple of times the creation of Kubernetes cluster with the help of CLI or the Azure portal. So let's go ahead and create one more by enabling the network policy. Because you cannot enable the network policy after the creation of AKS cluster, but you can only do when you are creating the AKS cluster. Just like enabling the Azure AD authentication, we have covered all that. So let's get into it. So this is the basic information that we have to provide in. One worker node is enough to perform the demonstration. Let's quickly go to the networking option so that I can click on advanced. Advanced is Azure CNI, and I'm using the network policy, Azure network policy, not the Calico. We have already covered what network policies are, when to use it, how to use it. We got two kinds, Calico and Azure. To use Azure network policy, we should have advanced network configuration, or you can say Azure CNI instead of Kubernetes, but Calico supports both. So let me click review and create. It will take some time, and meanwhile we'll talk about the steps that we are going to perform during this demonstration. So just a minute while it comes. There we go. So while it's creating, let's go through and see what we are going to do. Now, we know the network policies are two kinds that we have talked about: Azure network policies and Calico network policies. Two kind. Calico supports both kind of network plugins, Kubernetes and Azure CNI, but Azure network policy only works with the Azure CNI. In this demonstration, we are going to perform the Azure network policies, not the Calico one, but the concept remains the same. You have to perform the same kind of steps, just you need to be aware that's how it works. Okay, so this is our AKS cluster, and let's suppose this is our worker node, and these are few pods running, and these are the steps that we are going to perform in this demonstration. We are going to create an AKS cluster that we have already seen, and then we'll create a namespace. Afterwards, we'll create a pod with the backend, and then we'll try to access it. Of course, we can access, because we know that by default in AKS cluster, pod can talk to the other pods. Unlimited traffic, there's no traffic restriction, and that is why we have the network policies. Then we'll apply the network policies, and then we'll again try to access it. Then we'll apply the network policies on the basis of egress and ingress labels and namespace labels, so that we can see how it is working. A brief about it, and we'll see everything while we will be performing the demonstration. So let's get into it. Okay, so let's go ahead and get the credentials. Our deployment is done. So let's go ahead and get the AKS cluster credentials and work on it. Okay. We all know it's very simple. AKS get credentials. Okay. Then we need resource group. Very good. AKS RG. Then we need the name of our cluster, AKS cluster. Okay. Wonderful. Now we would have the information, our kube config file, and we'll be good to go. If we do kubectl get nodes, we would have a single node running, that is good enough to perform the demonstration. This is my pay-as-you-go lab, so of course I want to save money. Instead of the things that I could do with a single node for the demo, I do not want to spin up 3 nodes, right? So we have this, and now we need to go ahead and create the namespace. kubectl create namespace dev. Okay, I'm creating a namespace name dev. All right, it has been created. Now what we need to do, we need to label it as a purpose dev. So we need to do kubectl ctl label who label a namespace dev as purpose is equal to dev. Okay, kubectl get namespace. We have dev namespace. If we need to check our purpose or the label, we can do kubectl describe namespace dev. There we go. It says error because I did a mistake here. Namespace. There we go. You can see labels. Purpose is equal to dev. Now things getting interesting. Till now we have completed the steps that is required to perform the network policies demonstration. We created the AKS cluster. We get the credentials. Node is up and running. We have created a namespace so that we can apply the policy on the basis of namespace in upcoming steps. So for now, what we need to do, we need to run a container or a pod with the label as app is equal to web app. Okay, under the namespace dev. We got to expose it on port 80. All right, so how we can do it? It's very simple. I have this command, and this entire lab is or demo is there in the MS documentation that I will share it with you in the description box. So here we are going to run a pod with a label app is equal to web app. It's an Nginx image and has a backend, okay, under the namespace dev, and this is exposed on port 80. So let's go ahead and create it. Okay, if you do kubectl get pods, you would have this Nginx cube namespace. You see, we are in a wrong namespace because this is showing the default one, and we need to namespace space is equal to dev. There we see there is a pod named backend running in a namespace dev with a label app is equal to web app and role is equal to backend. Right now, what we need to do, we need to access this pod with the help of another pod where we are running an image is equal to Alpine. Okay, and we'll be getting inside the pod. We'll try to wget and see if we can access this or not. Now the error is because I have just copied this command from the MS doc, but I have a different namespace as dev. So this command kubectl run image alpine, okay, network policy namespace dev. I'm inside the new pod and we'll try to wget from here. Okay, not wait but wget, so that we can see that whether we can access the other pod or not. Yes, we can access. You can see the output. So this pod that we ran for the testing purpose with the -rm image alpine network policy, we can access the original backend image from this one, right? Now what we do, we will apply the policy, okay? Network policy, which will deny all. Rule would be applicable, okay? So what we need to do, we need to create a YAML file with the kind network policy, and the ingress is no one, like nobody can access this. I have the YAML file in place, I think. Okay, I have not exit out from there first. Let me exit it out. Okay, now if I do ls, I have this backend policy.yaml. Okay, if I do YAML, this is the policy, and I have this already because I was performing this demonstration, and I need to get rid of all this because this is the modified policy, and right now we are only applying the deny all policy. This is for the pod level web app that will come later. So this is our policy right now. Network policy is the kind, API version is v1, name is backend policy. For the namespace, right? Because our namespace is dev. Match labels app is equal to web app, role is equal to backend. Ingress, there is a square bracket, so it will deny ingress for everything. So let's get out and run this kubectl apply -f backend policy.yaml. Now this backend policy will automatically apply it on the pod that we ran earlier because that has the same labels. App is equal to web app and role is equal to, what was the role if you guys remember? Backend. Right now, since this policy is applied, let's get back to the testing pod from which we will run the wget again, just to see whether we can access the image or not. Okay, Nginx image or not. So we are inside the pod, and let me run the same command, wget timeout2 http backend, and this time it shouldn't allow us, and it's not allowing us because network policy says deny all. But now what we will do, we will modify the policy for ingress from any namespace, only allow web app and backend. Okay, so it's timed out. Now we need to exit it out. Exit. And now we need to allow inbound traffic based on pod label. Okay, so what we need to do, we need to get back to the same backend.yaml file, and now here we need to add a few things. So we only need to add ingress information here. Insert here, it was the 2 square brackets saying none, but now we need to, oh no, let me paste it here. It should not be like this. Okay, it should be under pod, right? Pod, it should be fine now. So you can see till now we have already covered. Now here we are changing the rule, ingress from namespace any. These are the match labels. Okay. Hopefully this will work. No space issue or things like that. Else I have to do it again. Oh, it worked. So we have applied this network policy, and now we need to go ahead and create the testing pod. Gotta remember this, a network policy uses namespace selector and a pod selector element for the ingress rule that we were doing that. I can show you again. If I need to do cat back in YAML, you can see namespace selector and pod selector. Okay. Now let's go ahead and create a pod with the information like labels which are allowed in the network policy. For example, app is equal to web app and role is equal to front end. Here you can see these match labels to the any pod can access the existing pod, right, on which the network policy we applied. So let's hit enter. We will get into this pod and we'll try to duplicate. Okay, so we are in. Let's paste wget. See, we can again able to access it because network policy allowed us, because we allowed the ingress as per the pod selector labels, right? Now what we can do, we can try the same test with the help of a pod which do not have any labels, and this would not be allowed to access the pod which has the network policy on the basis of pod selectors. You can see this should not be allowed, and it is not. Now if we need to do the network policy configuration as per the namespace, what we need to do in the same, let me exit it out from here, and if I cat backend YAML, you see under ingress we have from namespace and there is a square bracket. Instead of that, we need to do match labels purpose is equal to, or purpose colon develop dev or maybe prod. So that's how we can apply for namespace as well. Same concept is applied in almost all of the things, labels inside the Kubernetes. So we are applying the network policies on the basis of labels. Any pod which matches the label network policy is applicable. And any of the network policies as per the ingress or egress that applies on the basis of namespace selector and pod selector, whichever gets the match as per the rule defined inside the network policy would be applicable. And let me show you so that you can go ahead and perform the same demonstration that I'm doing with the help of Microsoft documentation. This is how, here they are talking about creating an AKS cluster. Here they have created the namespace as development. Here they are running a pod, Nginx pod with the labels, backend and dev that we have already covered. The last part where we have to define network policies as per the namespace, right? So there is the network policy as per the namespace. As I was saying already, same network policy, but instead of namespace selector for everyone, they have defined purpose equal to development. And then they're trying to access it and they are able to, right? So you can perform this demonstration with the help of this documentation. Well, that's all for today and thank you for watching. Bye-bye.